Hello everyone and welcome to the second part of the 3D morphing tutorial from HG Production. Uh, in this tutorial we continue on how we create this 3D morphing effect. In the first part of this tutorial we came until step 3, and right now we want to jump into step 4. But before jumping to step 4, let me just explain you something. If you have an object and you detach all the faces with the script, which was this script, I just pivot with resetting, you will have one for each face. You will have one separate object with the pivot aligned to the normal of the face and reset. But as you can see, we have here no smoothness. One way that we can solve this problem is that you render this out and you solve the problem with compositing. I think that is the better way. But another way, because if I go right now to here and see, I see all the edged faces and there is no smoothness. It's the best way that you solve this problem with compositing. But if not, you can select all the faces and go here to edit normals and select all the normals with Control A and here use threshold and select. But I think that is not a very good idea for two reasons. First, there are some faces that I don't know for what reason they cannot handle this, and you should do this manually for these faces that are not working correctly to adjusting the normals. And second, if you have a complex object with a lot of faces, it will be very heavy unless you have a good computer. Another stuff is that for example, you can say, okay, I like this effect, but I don't want to have each object as a single face. I want have them as one object, so it's no problem. After you did all this stuff, you can select all of them and go here to show. To show. And no outer amount, but inner amount, for example. And as you can see here right now, yes, right now all the faces have a volume. But if you also say that I like this way, the effect, the way, the approach of morphing, I don't want to fragment my faces with this effect, it's no problem. You can do this with your own way, to, for example, using Rayfire or whatever. So, until now, we have fragmented our object. The next step is to begin with morph. For this, I begin with the fourth step, equal faces. So the way that we want to approach this problem is that from easy to complex. First step, in each step we want to solve a single problem and go to the next one. In the first step, what we have is two objects or two group of objects. We can say object to all of them if you want. Each one has the same number of faces, 192 here, 192 here, and the shape of the faces are the same, so there is no morphing actually, but we want to have some particles that come from first object to the second object. Before we begin, we should select all the objects in one group and rename them. For example, I renamed them with first object underscore and a number. And here, these are my second objects. You can easily select all your objects and go here to tools, rename objects and rename it from here. Write your base name here and with the numbers. After you do this, you did this, let me unhide all and hide unselected. Just have my particle. I press 6 to or select here, and this is the code that we have that I should explain right now. As you can see, if I scrub the timeline, you can see that the particles are coming and forming the other object. Okay, but how to do this? So it is very easy. Just let me explain. The first step is this code. Let me select all this code, Control C, and make a new script so I can show it to you here, because here is very easier. As you can see in this script, we have 4 functions. These are events, okay? On channel use, this is initialize, this is on proceed, and the last one is release. Here we have nothing to do with this release, so I can delete it here, not here. So I just delete it here for being easier. So there is only 3 main event or function that we have to deal with. The first is use channel. In the use channel, you have to say which property of the particles you want to use in this script. I want to use the age, transform, TM from transform, the shape, and use matrix. These 3 are very easy to understand, but what is this use matrix? Use matrix is a matrix variable which you can use it after. It's an empty, just like an empty buffer. You can imagine this, or an empty glass which you can put some matrix into it. So here I say that I want to use these 4 properties of my particles, and in initialize on init here, I have to say this code will run just once. For initialize is it? I say select all the objects that their name begin with first object. You see the dollar, it means select these objects and put them as an array to this. Right now this first fragment is an array which are all my first object into it, and this is a global variable. And another global variable which we have here, the second fragment. And then what we have here is we define here a max p count, which will be our first fragment that count. So I want to know how many fragments I have in one group of objects, which is here in this case 192. You can also write this, so copy this here, Control X, and paste this here and delete this. It's the same. Okay, so after this I go to on proceed. On proceed is the function that will apply, that will implement it in each frame. Okay, and what we have here, we get the get time start from the particle container and convert it to float. As a float passes to the variable named t, and say if the t is less than 0, it means if it's in the beginning of our animation. Okay, so if the t is less than 0, do this. What should we do here? We say p count is my particle container. P count that add particles. Add particles is a function which add particles, and you should give a number, and they will produce as many particles as you have here as a number. So in our case will be 192 particles. So we have created right now 192 particles, but there are 2 things that we will have to do. We should say the position of them and the shape of them. Okay, we should define these 2. But before we do this, before we do this defining, because this defining is here. Okay, I want first go to the second object and just store the transform of it, because I need it later. So I say make a loop. Okay, this is a loop. I hope that you are familiar with loop. From I equal to 1 to max pickup, it means this code will implemented 192 times, and each time it comes, the I value is another a number, and another number, for example 1 2 3 4. And right now in each time we say, okay, we have to deal with which particle ID, the first ID, the second one, the third one. So each one that we are coming to the loop, we have to deal with the next particle. We say, okay, the particle that the particle that is right now selected, or that we have to deal with, make the age of it to 0, and fill the particle matrix with second fragment that transform. As you see here, I say to you, it's an empty glass or an empty buffer or whatever, an empty variable you can say, that you can store stuff inside it. I say store the information of the transform of the second object. Which object of this array? The ith object, the end number. Okay, put it here. After this is finished, now I wanna I go to my first object and say, okay, repeat this this loop from 1 to 192. Select the particle, and this time the particle transform should be my first fragment object. Which object? The ith object, the first, the second, and take the transform and apply it to my particle, and take also the mesh of the first fragment and apply it to my shape. So right now what I have here, I close this. No, what I have here is that I have all my these are all particles. If I change the display from geometry to something else, some circle, these are all the particles, and the particles are they have their own transform and their own shape. After this, just let me here and hide the space wrap as helper. I have here an deflector, and it has a keyframe in Z position, and I say here, if you have any collision with this deflector, go to the next event. But before this, I have a data operator here, and here in input standard there are many inputs from my particles. I go here to script and the matrix. This is the same value. This is the same value that I have here. This is this use matrix, the information that we stored here. I take it from here and put it to a variable, to another matrix variable that is readable for data operators. I can directly use my script matrix, but I think this is a better and more secure way. But I do a new event. It means just one time, just the first time that each particle are in this event, this code will apply. If you do this new in event as a filter. So right now I am here. After collision, I came to here. Here I have a data operator in which I say reset the age. I have here the particle age as my output standard, and that is once again new event that will apply just in the first frame. And I have a number here 0, and convert this real to time, and say, okay, all the particles right now from here, the age will be 0. After this, I want to send them to the next event when the test age value is, the particle age are more than 40. But before do this, I have a rotation, but I don't want to have the particles after coming to this event having this random rotation. When you apply also a go to rotation and you have an event duration, for example for 50, it means that go to this rotation that you have in your event in 50 frames. So, and I have also a random for randomizing the position. If I scrub the timeline, you can see here we are right now in this green event, and you see this shape that it's forming. This is because of this random walk, and the rotation of each phase, which is a very smooth rotation, is because of my rotation. After this, I come to the next event. In the next event, I extract the rotation info that I had here from my data operator from here, from the second transform that I had here. And I extract also my position. So I need them. Why? First, I get the rotation. And how can I do this? I have here my second transform. I converted matrix to quaternion, and I apply it as output standard rotation quaternion. And I do this just one time, just the first time that each particle came to this event. And then right now I have rotation here, and I say go to this rotation in 10 frame. So each particle that came into this frame, in 10 frame, the rotation will be the final rotation. And I also have a get pose, which is the same, but instead of quaternion, what I have here, I have once again my second transform, but here matrix to vector, and which vector? The translation. Okay, so I need it, and I output it to my script vector. Why I do this? Because in find target you can have you can use your script to define where the particle they have to go. Okay, so they should go to this script, so they will go to this position, and in 10 frame they will have this rotation, the final rotation. And after the blue one, we will see the red one. So just scrub the timeline to see how it is. The blue, and the end is the last. In the end, we have two stuff actually. This is the display. First, I say 0 the speed, and second, I say second transform to the matrix transform. Why I am doing this? Because in find target, you have your test true, so it will go to the next event if the distance is less than 1. It means it can be slightly a reposition in your object, slightly. If you turn this to 0, it can happen that the particle cannot find their own final destination. So it's better to keep it to 1, but when they are here, say them, okay, right now I know that you are in the right position, but it can be that you are slightly in a different position. So once again, for the last time, I have the final matrix with transform, scale, rotation, position, and apply it to my whole transform matrix. So you get sure that the particles coming to the final end position, and this is the result. So this was actually the fourth part, the equal phases. But let's see what is our next step. Step 5, morph change phases. In this example that you can see, I have once again two group of objects, but these two group of objects have the same number of faces, 192, 192, but the shape of the face is different. I have just select all of them and applied a bend to it, but there are some other faces here and some other faces here. So we have to solve the problem of morphing between these two. And how to solve this problem? I select both of them and hide all and hide this. So I have just my particle. And once first I scrub the timeline to see the result. Yeah, you can see that also the faces are changing from this to this. So how it's happening, I go once again here, and what I have here in my bed, a little more, no, yes, a little more stuff, not here, not. As you can see, we have the same usage, we have the same global arrays that we have defined here, and our max particle counter. And first, what we do here, we go through this loop and store the matrix, the transform of the second one, and here apply the first one. But this is, I just turn this off so you can see without material, so we can see the color of the events. This is the first event, this is the second event, the same. But when we came to the next event, to the blue event, what will happen? When we came to the blue event, you can see that the faces are changing from the first group of objects to the second group of objects because of this script operator. I go to this script operator and see what is going on here. So I have used just the shape. So just use the shape property of our particle. And there is nothing for initialize and nothing for release. Just a simple loop that says go through all the particles and take the, say which particle ID is right now selected, and what we want to do, change the shape to second fragment ith mesh. So you may say that this is obvious, we can see that these faces are changing, and that's not true. But I tell you something, when you have more than 100,000 faces or objects and they are moving fast with the motion blur and all this stuff, so there will be no big difference. You cannot see. And if you see here in the final version, can you say me when these particles are changing their shape to other one? No one can do this. You can also do some variation in coming to the next event, and the size are slightly the same, and the motion, everything. So somewhere here between, let me say you, somewhere here between, they are changing their faces, but no one can see it. This is the magic, man. Okay, so that is the point, but the other stuff is the same. So we are finished with the fifth step, and we want to go to the next one. Step 6, morph destination problem. What that means? Okay, just let me load it, and before we load this, let me explain to what the problem is. I have here in the 6th also a movie. Let's play this. You can see that the morphing, right now we have all my fragments, and the morphing is okay, but they are coming randomly to their places, and this is not looking good. Why? Because from now you can see that it's a 4, okay? But what I want to have is that they come from top to bottom or from left to right or something like this. I want to say, I want to have full control how the morphing ends. This is not a beautiful thing, and this is not what I want to have. So this is the morph with destination problem, because here it's everything good, the begin is good, this is good, but here this is not good. So this is the next step, and you can see here in our simple sample file, we have an object here, and this object we try to transform it to the next object, and somewhere here between the faces are changing and nobody can see it. It's looking not good with this destination problem. It's not a good thing, but this is another step. So the morph is completed. I bring it back and select my particle, hide it, and bring my geometries. Yes. Okay. These are my geometries. Okay. I select also this here, hide this. You see, I have two geometries. The one geometry, which is the first one, here we have 1000 objects, but here we have 1176 objects. So here we have more. But let me, before going through this code, select the geometries, hide them. Let me explain you something. So we have two cases. If the first object is more, then the particles that are coming to the next, they should disappear somewhere in the middle of the event. But if the second object has more fragment, so what should happen? Then we should have more from the beginning. So the way that we want to do this, we say we will create as much particle as the highest number of these two. So if, for example, here in this case that we had 1000 here and around 1200 here, we will create 1200 particles. But the problem is that these particles that are first in the first object, just 1000 of them had their own shape and place, and not the others. So how we can do this? So the way that we want to solve this problem is this. There is once again the script operator, and I go there, I select all of them, Control C, and once again I came here, a new one, Control V, so it's easier to explain here. What we want to do here, once again, these 4 channels, age, transform, shape, matrix. But here in initialize, after we collect our two group of objects in these two arrays, I create also another variable, a Boolean variable, and its name is first more. It's a question variable. It has a false or true. It asks, is the first group of objects, has the first group of more particle or not? And it's a simple if here. It says if the first number of first fragment is more than second, then is first more is true. But if not, is first more is false. So if the first is more, so our max particle count will be equal to our first fragment count. And if the second is more, the max will be as much as the second group. So that is why we should have first create the variable here, and after that apply the value to it. So after that we came here to the proceed, and we say if it's in the first frame, okay, if it's in the beginning, I explained that earlier, so I skip you and I come here, okay, and I told you this first and this first if is for applying in storing the particle matrix, so where the destination of the particle is the second object, and the second if that I have here is for defining the current particle state, which is the first group of objects. So but first let's see how we solve this problem with storing the transform of the second object. So I say if is first more is false, it means if the second group of objects has more particles. So if the second has more particles, so there is no problem with storing all this transform information. So do the same thing as before. But if not, if the first object has more, in this case what we should do, we have a if I, the number of particles that is current selected, is greater than second fragment that count. It means, for example, here we had 1000 and 1200. If it's until 1000, so there is no problem. If it's less, if the particles, the number are less, then do the same as here. Okay, for example, from 0 or from 1 to 1000, but there are another 200 particles that should be stored the position. But the second fragment, if the second one is less, there is no place anymore. So what should we do? Very easy. We say, don't worry, place it on your brother's place or your neighborhoods. Then so we choose, we select the ID. We say this particle is selected, make the age 0, but here is the code what we want to do. We say okay, we have here a particle number, and we say P contain a matrix. The transform of this particle will be the second fragment particle number. So because we have only 1000, but this one have more, so how we should solve this problem? We do this with this mode, and if we don't know what this mode is, I can just show it to you. Control R delete. For example, if you have mode, this is a function which you give two numbers and a number will come out. For example, I say 1 and 10. It means the remainder. So the remainder of 1 for 10 is 1. The remainder for 2 is 2 until the 9. Okay. But if I go beyond this, the remainder of 10 divided by 10 is 0. The remainder of 11 to 10 is 1. So it says, if right now, if you reach the maximum of this fragment and you have no place, there is no place for you to store any position, okay, no problem. Make him with this mode function. For example, if you are, for example, here, for example, if you have 100 objects, and this is the 101, the I is 101. It will be so mode 101 and 100. This mode will be 1. So you came once again to 1, and the count minus 1, which will be 100 minus 1 minus 1, which will be 99. So once again you go downwards. So you choose the object, the 99th object, but you give this transform to the particle which has the index of 101. This is the point. You select the next time the fragment that has the the transform of the object that is in the 98, but you give it the ID, you give this transform to the particle which has the ID of 102. So in this case, if there are more particles in the first one, this problem will be solved here. They will sort in somewhere else. Also here, and after right now we came to the next part. Right now we store just the particle matrix. Here we want to store, we want to give the particle the transform and their shape. Okay, and we use the same technique. We say if first is first, more is false. It means come to this if the second is more. But if the first is more, come here. So if the first is more, there is no problem. But if the second is more, and right now you want to store the first, so there will be some problems. If the number is less than first fragment count, do as you did it before. But if it comes more than it, with this mode, okay, place this object to the neighbors, to another object. So with this code, you have solved the problem. We have solved the problem. So it's not necessary to have an equal number of faces. If I go here, oh sorry, if this one is more, then the particles that much particle will be created, but when they are coming here, they will disappear somewhere here. But if this is more, some of the particles that should be here, 2 or 3 of these particles should place in the first frame in one place of this object. So they will be at 2 or 3 in one place, but after they are flying through the air, they will separate themselves. That's the magic. That's the point. And hide all. Hide selected. But that's not the end of the problem. After we did this script, we have once again our data operator, which we store our second transform. And I have here a collision from Krakatoa collision, which is a very more accurate and better and faster collision. With the plane, I have just a plane and say collide with this plane. And if it collides with this deflector with normal collision, go to the next. And here I have a reset edge. And in this reset edge, what I want to do, okay, I don't need this because this is for the next step actually. So I can skip this. I mean, I can, this is for the next, I can skip this, okay? I can delete this, I don't need it here. What I need is just here. I just reset the edge and go to rotation, which rotation, this random rotation. And there I have here some forces to have some more fancy look, but that's up to you. That's not what I'm interested of. And after a certain of age, go to the next event. And in this next event, we had a script, if we can remember. And this script, we said, change the faces. Right now, we have to change this script part. It should be somehow more complicated. So, it is the same, but we should say here, once again, if the first is true, do this. If the first object is more, and else do this. If the second object is more, then you have no problem. Just say where the particles is. That's the same code as before. But what if the first object is more? So there will be particles that they should disappear during this time. So that is how we do this. We say, for example, 1000 particles were at the first, but right now we need just 500 of them. Okay, the first 500 they should find their position in the second object, but another, for example, 500 that they are right now they have no place for the second object because the second object was less. We say, okay, these are particles, the scale of them should in each time that we came to this frame went smaller and smaller. So if you can play with this number and you can disappear them sooner or later. That is up to you. The way we do this is this. We say it's a loop and say if I is more than second fragment count, come to here. If you encounter particles that have no place in the second object, okay, then let disappear them. But here, you are playing just with the scale of the particles that have no place in the second object. I hope it's understandable. And here we have our final rotation. It's the same code, and this is also the same code. And when we came here to the last event, there will be a problem. But after we stop the particles, we can also stop the particle like this. After we stop the particle, we apply the final transform. And the final transform that we are applying for the whole particles to the 1000 particles. But some of these particles they should have the scale of 0. And if you apply a transform, the transform is for the whole matrix. So how we should solve this problem? We need to do this, but we need to say, okay, we do this, but the particle that has no place in the second object, they should have the scale of 0. So therefore I have another script here and say, once again, with which channel I'm using, I am using the scale channel. I say if the particles are more, if I more than second fragment count. So if you have more particles, the particles that have no place, okay, their scale should be 0. So I don't want them to want you to show them, and that is the magic, man. Okay, that is the way. I hope that it's understandable. I'm trying to make it short. You have this access to this file. You can see them, play with them, and if any question, feel free to ask me. Okay, it's a little bit complicated, I know, but if you one time understand it, then we will see it's not that easy as you see. Okay, we want to go to the next step. The next step, what we want to do in the next step is solving the problem for the destination, for the second object that is morphing 2. So for this I have sample C. Here I have some objects, and I want you to understand the way that I'm approaching one problem. And I rename them with frag. And also I also read a code, write a code. My code is this one. This code, what is doing, it say take all the objects that begin the name fragment. It means all these objects, and let's just skip this function, and I say Q sort. Q sort is a kind of sort for the array in max grid. If you go here, Q sort, you can see that you should give the Q sort your array and a function that this array will be sorted based off this function. And in this function you will have 3 outputs. Okay, the comparison function must take in 2 values as argument and return an integer number. If the number is less than 0, if the first value is less than second value. So if the first value is less than second value, it will be less than 0. 0 if the values are equivalent, so if both the object has the same value, and an integer number more than 0 if the first value is greater than the second. So you should have 3 output: -1, 0, and 1. So this is that what we have. I have a function and I have an object 1 and object 2 as inputs. I take this object 1 and object 2 and I take the position, and I'm right now interested for the z position. So I extract the z position of these two objects, this v1, this v2, the z position, and I put them in these two variables. And I say case of, if z1 is less than z2, so return, this function will return -1. If z1 is greater than z2, the function will return 1. And else case, whatever happens, return 0. So based on this function, I say sort all my fragments, and after you sort them, I just get the count and say, okay, go through all the particles that are right now sorted, and I just want to apply change the wire color, the color of the object. You can see that this kind of Q sort is working. We have 3 components for color: red, green, and blue, and I just want to change the second component, red, the green one. Okay, and I have here current percent, which came here as a variable, and this is just the percentage of the value. So let's just apply this code and see what will be the result. So I just select run script, step 7, array sort, and well, right now you can see that the color is changing based on the Z. So we are using this code to solve our problem. And so is it that we go to the 8th and the final. Here you can see that we want to use this code. Here you will see that in our max script, in our initial init p count do, we have the same function as before that I explained right now. And after all this is happening, what I explained earlier, I sort the second fragment and the first fragment with this function. So right now I have sorted this. So right now I sorted all the particles based, here I have sorted them based on the Z position. But how to use this, okay? This is another problem. These stuff are the stuff that I explained earlier. But how to use this? I came here first to the reset age, and the way that I'm using this was the code that I had earlier, but this is a new code right now, because right now they are sorted in a way, the index, okay? So if the index is 1, it means it's at the bottom of the group, okay? So I want to take the bit and take the bit index, the index of objects, and store them in an variable. I named it Q number, and I want to do this just in the first frame, but I want to have them on offset, and you will see why I am using this offset. After that, you can change this offset for your own purpose, okay? So for example, the first one will be 501, the second one will be 502, 503, and so on, based on your offset. After this, instead of having age test here, I have a data test, and I say go to the next event based on the sorted information that we have here, okay? See if you are, if it's right now your turn to go. How to do this? We have a data test, And in this data test, we say in each time we come to this data test, because you can see if I select this, the execution order of this event is 1 and the execution order of here is 2. So first we have our queue number and we subtract it with 100. So for example, if it's a 500, here it will be 400. And we store it once again in queue. So each time, each frame, each particle will subtract with 100. So if you want to go quicker to the next event, you can have a bigger number here. If you want to have them go more slowly to the next, you can decrease this number. Okay. After you change this queue number each frame, you will say in the second execution order, if this number is less than 0, then go to the next event. So there is that the particles are going to the next event based on their z position. And when they are here in the next event, let's see what we have in script. In script is the same, here it's the same for changing their shape. There is some random walk and the other stuff is the same. There is nothing new. So, and so is this, that if I scroll the timeline, let's just play. My computer is a little bit slow, but you can follow it. You can see that the particles are going from the one object, and based on the z position, they will shape the second object. And that is the magic of real morphing. That was something that I was searching for a long time. And I was searching in the internet and hope that someone could solve this problem, but I didn't know that I am the one that I should it. So that was the last step. I have also the ninth step. The ninth step is my own sample work, knife fork, that you can, I let it also in the stuff that you have access to, so you can see it. It's very simple, but for my computer a little bit heavy. My computer is not a very good one. And you see that I have one object that will transfer to the second object, and the code will be exactly the same. So that was the tutorial about. I hope that you learned something, and I want to see your work in YouTube. Create some cool stuff with it and let me know. And if you learned something, don't forget to subscribe me, okay? And if you have any question about this, feel free to ask me. Okay, then I wish you luck with this code and enjoy it and have a nice day. Bye.